Let's look at another trapezoid approximation problem. Now, for this one, guys, notice that you don't even have a function. You don't even, so therefore you can't even take an antiderivative because this is just simply a table of values. So the question is, what if you aren't given a function? What if you're only given a table of numbers? And what if the intervals are not of equal length? So we can't use that trapezoidal rule that we just did. However, we could try and map this out to get an idea of what this looks like. So what I'm going to do is I'm just going to draw a coordinate grid. It doesn't have to be perfect, and obviously x goes there and f of x goes here. Notice that my x values are going to go from 3 to 15. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And notice my f of x values go up from 10, 20, 30, 40, and 50. All right, so let's plot our numbers. So the first one is 320, so 320. The next one is 740. So 740. The next one is 950. So 950. The next one's 1030. So 1030. And the last one's 1510. All right, so those are my plotted values. Now, obviously, I don't have a function to that could connect all these. However, I could draw trapezoids to approximate this area. How am I going to do that? Well, I'm just simply going to drop down, straight down for each one. And then I'm just going to connect these points. And if you notice, each one of these shapes is a trapezoid. Now, they're not the same width. However, they are all trapezoids. Now, one way that I can approximate it is if I can find the area of each trapezoid and then add those areas together. All right, well, if you've forgotten, the formula for a trapezoid is a plus b divided by 2 times the height. Now, this is what's crucial, guys. With these trapezoids and all the ones that you draw for these problems, a and b are going to be these lengths, and h is going to be the width of our trapezoid. So this value is 20. This value is 40. So what I'm going to have is, I'm going to move it up a little bit. For the first one, I'm going to have 20 plus 40 divided by 2, and I'm going to times that by the width, which in this case is 1, 2, 3, 4. So that's going to give me 40 plus 20 is 60, divided by 2 is 30 times 4, so that's going to give me 120 for the area of that rectangle. All right, for this one, my height here is still 40. My height here is 50, so I'm going to have 40 plus 50 divided by 2 times my width. In this case, it's 2. So 40 plus 50 is 90, divided by 2 is 45, times 2 is 90 again. So this trapezoid is 90. All right, let's do the next one. This is still a height of 50, but this is a height of 30. So I'm going to have 50 plus 30 divided by 2, and we're going to times this by the width, which in this case is 1. So 50 plus 30 is 80, divided by 2 is 40. So this area would be 40. All right, and then for the last one, this is still 30, but this height right here is 10. So for this trapezoid, I'm going to have 30 plus 10 divided by 2 times my width, which in this case is 1, 2, 3, 4, 5. All right, so 30 plus 20 is 40, divided by 2 is 20, times 5 is 100. And so now I have the areas of each one, so I'm just going to add 120 plus 90 plus 40 plus 100, and that's going to give me my final answer, 9, 10, 11, 12, 13, 14, 15, 1, 2, 3, which would be 350, and that's an approximation of the area.